VLSos here. This is a video lesson on arithmetic series addition, which is not so much a topic in math, but more of a description of what we're going to do to practice using series. I'm going to define a series, S sub 1. S stands for sum, stands for series, because a series is the sum of a sequence. If we have a simple sequence of numbers and we add it together, we produce the series. And we can generalize finding the value of any of these terms with the expression n. In general, we use n to designate the position number of a term in a sequence or series. And this sequence of numbers is so simple that the value at any place or any position is the position number. This 4 is a value of 4, and its position is also 4. I'm going to create a second series we'll call S sub 2. The sequence is 2, 4, 6, 8. The general expression to find the value of any term is 2n, or 2 times its position number. And if we add the sequence together, it produces the series. We'll recall that the notation t sub n represents, in general, the value of the term at position n. We have two series here that's defined, and we're going to do something to produce a third series that we're going to call S sub 3. We're going to produce S sub 3 by adding the two series, S sub 1 and S sub 2. We can see what happens to each term number. The initial term in both series add together to be 3, then 6, 9, 12. And if we add the general expressions to calculate term values, n plus 2n is 3n, which it produces a third series. This third series, we could think of its qualities. It's arithmetic. It's arithmetic because just like series 1 and series 2, it grows by a constant difference. The rule is we add 3 each time. So we could say, and use as part of the equation, that d, the constant difference, is equal to a positive 3. How many terms does it have? This ellipsis means that there is a process that is continuing, and it may be too lengthy to show on paper, but in all these series, we don't see that ellipsis symbol being used after the expression. So these series have an ending. They stop. They don't go on forever. So the number of terms is going to be unknown, but a finite value n. The series stops at n, whatever n may be. So they have n number of terms. And if we have an arithmetic series that stops, doesn't keep going, then we will be able to calculate the sum or add together all those terms. And to do that, we do have a formula. But the formula to find the sum of a series takes this clever idea of adding together the first and last term to produce a quantity. And that sum of the first and last term will be equal to pairing together the next term in the series with the next to last. Because there's a constant difference, we can add up two terms and match them all so that they're all the same sum. That means that formulaically, we could produce the sum of two terms simply by adding the first term, t sub 1, and the last term, t sub n, to get the sum of any two terms, and then multiply by half the number of terms that are in the series, or n divided by 2. If you're not sure how we were able to produce this formula, then you're welcome to just apply it. In this case, S sub 1 using this formula means that we're going to find the sum of all of these terms by adding the first and last term, 1 plus n, and then dividing by the number of terms divided by 2. This expression stands for the sum of the first series. The second series, using the formula, is the first term 2 plus the last term 2n, which we don't have a value for, but we can still express it this way, times n divided by 2. And if we produce the third series by adding the first two, and the sums of the first two are given by these two expressions, then S sub 3 can be shown as the expression for the sum of the first plus the expression for the sum of the second. Now I have an expression for the sum of the third series, but I can simplify it. Both of these terms have a common factor of n divided by 2. So I'm going to factor out n divided by 2 from both these terms. What's left of this is 1 plus n. And when I factor out an n divided by 2 of the second term, what's left is the 2 plus 2n. One more step, I'm going to combine like terms and get n divided by 2 is equal to the 1 and the 2 combined to make 3, and the n and 2n combined to make 3n, which unsurprisingly should look like the formula when applied to what I know the third series to be. The formula is the first term plus the last term, or 3 plus 3n, times n divided by 2. So I have confirmed that the formula works and works exactly like I'd expect if I did it by hand.